Okay, so what is the Stone represent theorem? Every Boolean algebra will always be isomorphic to power set algebra. So what is meaning of that? In the set of Boolean algebra, it is equal to the in element. Okay, in the set of Boolean algebra, if it is Boolean algebra, then it is contain 2 raised to n element. Okay, if it is a Boolean algebra, then you can use this to check the element. That is, element is always equal to 2 raised to n form. Means for 2 raised to 1, then after 2 raised to 2, 2 raised to 3, 2 raised to 4, and so on. Okay, means that is equal to 2, that is 4, 8, and then after 16. So the set of Boolean algebra, if it is satisfy all the condition of Boolean algebra, then it is contain this type of element. Okay, either it is a 2 element, 4 element, 6 element, 8 element, and 16 element. It never will be 6 element. Okay, we cannot say the set contain the 10 element, which is the Boolean algebra. Okay, so if it is contain, it contain always the 2 raised to n form. Okay, if it is a Boolean algebra. And you can also check that S1001. Okay, how many element in S1001? S1001, that is we already proved it is a Boolean algebra. So why it is Boolean algebra? Because it contains the element, that is 1, 7. Okay, these are the divisor of 1001, 11, 13, then after 77, 91, 143, and 1001. Okay, so check the element. There are 8 elements here, 4 and plus 4. So therefore it is a Boolean algebra. Okay, and if you consider the S64, okay, how many element in S64? That is S64. Okay, that is a 1, then after 2, 4, 8, 16, 32, and 64. How many elements? That's 7 element only. Okay, so we cannot prove it is the Boolean algebra. Okay, means we cannot find complement of each entry, and you can easily check that complement of 1, that is 64, but we cannot find complement of 2. Okay, we cannot find complement of 3, 4, and 8, and so on. Therefore it is not a Boolean algebra. But S1001, it is a Boolean algebra. Why it is Boolean algebra? You have the two way to verify that. Okay, one is a definition, and second one is a Stone represent theorem. If the element are equal to the power set algebra, means a 2 raised to n form. Okay, the element in this set should equal to the 2 raised to n form. N is maybe 1, 2, 3, 4, 5, and so on. Okay, so if the set contain 2 raised to n form element, then we can easily say it is the Boolean algebra. Okay, so that is a counter example is S1001. It is a Boolean algebra because it contains the 8 element, and we can easily apply the definition here to check it is Boolean algebra or not. Okay, and second one, it is not a Boolean algebra. Why it is not Boolean algebra? Because it contains the 7 element only, and it is not a 2 raised to n form. Okay, 7 is, we cannot write 2 raised to n form. Clear? So it is not a Boolean algebra. So here the Stone theorem that and by using this so the procedure, we can identify that how many sub-Boolean algebra it will contain. Okay, so Sn represent the Boolean algebra. Then case 1, if the sub-Boolean algebra of Sn contain the 2 element, then the form will be S is equal to 0 and I, 0 element comma I element. Okay, if it is contain sub-Boolean algebra of 2 element, then what is the form of this one? That is S is equal to 0 comma 1. Okay, then after case 2, if it is contain the sub-Boolean algebra of 4 element, then how we can derive the sub-Boolean algebra of 4 element? So first we'll identify the atom of the Sn. Then the S can be defined as a 0, then after A, n by A, and I. Okay, this contain the 4 element, 0 element A, which is atom, then after n by A, n is the last Sn. Okay, then after I, it contain the 4 entries that, so it is a sub-Boolean algebra of 4 element. Okay, and it depends on the atom. So if it is contain the 3 atom, then we'll get a 3 set. Okay, if it is contain the 4 atom, then we'll get here 4 set, and so on. And then after case number 3, if it is contain the sub-Boolean algebra of 8 element. Okay, so how we can derive this set? So that can be defined as a 0 a n by a, then after b is the second element, second item, that b n by b, then after LCM of ab and n by LCM of ab comma I. Okay, so this is a formula we have to predict the sub-Boolean algebra of 8 element. Okay, consider any two atoms of the set a and b are the atom, 0 element, then after a n by a. Okay, then for b n by b, and then after LCM of ab and n by LCM of ab comma I. Okay, so this way you can check the sub-Boolean algebra for a 2 element, for a 4 element, and for a 8 element. Okay, so let us consider one example here, S105. Okay, and we have to identify the total sub-Boolean algebra, means after we'll take it addition. Okay, how many sub-Boolean algebra for 2 element, how many sub-Boolean algebra for 4 element, and for 8 element, and so on. Okay, and then after we'll take it total at last. So first we'll identify S105. So S105 is given here 1, 3, 5, 7, 15, 21, 35, and 105. Okay, this is the divisor of 105. And now its atom are 3, 5, and 7. Okay, you can also use the definitions to find the atom, and if you directly know, okay, it is simple that to predict the answer of atom 3, 5, and 7. Okay, why it is 3, 5, and 7? Because these are the covered by 0 element, and 0 element is here a 1. Okay, so we have the 3 entry, 3, 5, and 7 are the atom. And now in case 1, we'll identify the sub-Boolean algebra which contain the 2 element. So what is the formations for that? S is equal to the 0 comma I. Okay, and 0 element is here 1, and I element is equal to 105. So S write as a 1 comma 105. Okay, this is a sub-Boolean algebra of S105 which contain the 2 element. Okay, so that is answer number 1. Then after case 2, we'll identify the sub-Boolean algebra which contain the 4 element. Okay, so formula we have S is equal to 0 element, and after A is an atom, n by A, and the I. Okay, so we have the 3 atom right now. So use one by one. Let us consider A is equal to 3. So answer will be 1 comma 3. Okay, 1 is the 0 element, then after A is equal to 3, and n is equal to here 105. Okay, Sn. So n is equal to 105 divided by A. Okay, so 105 by 3 comma I element. Okay, so I is equal to here 105. To simplify that, we get 1, 3, 35, and 105. Okay, so that is the first set which contain the 4 element, which is a sub-Boolean algebra of S105. Then after second one, use the second item. Okay, A is equal to, let's take a 5. So the formations will become 1 comma 5. Then after 105 by 5 comma 105. Okay, so simplify that, we get 1, 5, 21, and 105. And then after third one, use the next atom, that is the third is value is A is equal to 7. So use A is equal to 7 in this formula. So it will be a 1, then after 7, 105 by 7, and 105. Okay, formula will be same that in each case you just replace the different atom. Okay, so we get a 3 set, okay, which involve the 4 element and which are the sub-Boolean algebra of S105. Okay, and now third case, the sub-Boolean algebra of Sn of 8 element. Okay, so the formula we have is the formula S is equal to 0 element, then after A, n by A, B, n by B. Okay, then after LCM of A comma B, and then after n upon LCM of A comma B, and then after I element. Okay, this is the formula. So consider any two atom as a and B. You have the three choice, okay? 3, 5 and 7. So consider any value as a and B, okay? Either 3 and 5, either 5 and 7, otherwise 3 and 7. So let's consider A is equal to 3 and B is equal to 7. Okay, now let's take 5, 3 and 5. So now replace in this formula. So we get here 0 element is equal to 1. Okay, replace here 1. Then after A is equal to 3. Now n by A. Okay, so n is equal to 105. So write here 105 by 3. Then after B is equal to 5. N by B 105 by 3. So 105 by 5. And then after LCM of AB. So LCM of 3 and 5. And then after n is 105 upon LCM of AB, or LCM of 3 comma 5, and then after I element is 105. Okay, so now simplify that 1, then after 3, 105 by 3. Okay, that is a 35. Okay, then after 5, 105 by 5, that is a 21. LCM of 3 and 5, that is a 15. Okay, and 105 by 15. Okay, so we'll get 35, and then after 105. So we get all the value here 1, 3, 5, 7. Okay, then after 15, 21, 35 and 105. Okay, so this is set of sub-Boolean algebra which contain the 8 elements 1, 3, 5, 7, 15, 21, 35 and 105. Okay, we just derive it and after rearranging this increasing or the decreasing order. Okay, so 1, 3, 5, 7, then after 15, 5, LCM of 5 and 3 will be 15, 105 by 15. Okay, 7, then after 105 by 5 and 105 by 3 will get 21, 35, and the I is a 105. Okay, and now find the total. So total number of sub-Boolean algebra for a 2 element, it is a 1 set. That for a 4 element there are 3 set. Okay, and for 8 element we have a 1 set, 1, 3 and 1. So 1 plus 3 plus 1, that is equal to the 5. So total sub-Boolean algebra will get a 5. Okay, similarly for second example, S30 GCD LCM dash 0 and I. So let us check for S30. First, let us check the element of S30. So S30 is equal to 1, 2, 3, then after 5, 6, 10, 15 and 30. Okay, 10 and after 15 and 30. Clear? This is set of S30. And now the atom of S30. Okay, you can also consider S diagram of that, find the cover element, okay, join element, and then after you can check the atom. But we can directly consider it here 2, 3 and 5, which are the cover of 0 element, means 1. So atoms are 2, 3 and 5. Okay, these 3 value are the atom. You can also verify that. Okay, so let's verify it. And now we'll identify the sub-Boolean algebra, total sub-Boolean algebra that we'll identify. So first in the case 1, okay, sub-Boolean algebra for 2 element. Okay, so that is equal to S is equal to 0 element and the I element. So 0 element is here 1 and the I element is here 30. Okay, so there is a 1 set which contains the 2 element, which is a sub-Boolean algebra of S30. And now in case number 2, okay, we'll identify the sub-Boolean algebra of 4 element. So we have the atom is equal to 2, 3 and 5, and we have formula for that, that is a 0 element, and after A, n by A and the I. Okay, so use A is equal to 2, 3 and 5. So we'll get S is equal to 0 element is here 1. A is equal to 2. N by A. So it is a 30 by 2. And I is equal to 30. Okay. So that is equal to 1, 2, 15 and 30. Okay. Then after S for A is equal to, let us take 3. So 1, 3, 30 by 3 and then after 30. Clear? So that is equal to 1, 3, 10 and 30. Okay. And now third one, S is equal to, let's use a 5, 1, 5, then after 30 by 5 and the 30. Okay. I element. So that is equal to 1, 5, 6 and the 30. Okay. So this three set we have, which are the sub-Boolean algebra, which contain the 4 element. Okay. And now for case number 3, identify the sub-Boolean algebra for 8 element. So here formula for 8 element is equal to 0 element n by a, okay, b n by b, then after LCM of a comma b, n upon LCM of a comma b, and then after I element. Okay. So consider any value as a and b from the data. Okay, 2, 3 and 5 we have the 3 choice. So let us consider 2 and 3. So 0, a is equal to 2, n by a means 30 by 2, then after b is equal to 3, n by b means 30 by 3, and then after LCM of 2 and 3, and then 3. Okay, and then after I is equal to 30. Clear? So simplify that. 0, 2, 0 element is here 1, and then after 2, 30 by 2, that is a 15, then after 3, 30 by 3, that is a 10, LCM of 2 and 3, that is equal to 6, and 30 by 6. Okay, LCM of 2 and 3, that is equal to 6 here. So 30 by 6, that is equal to 5, and I element is equal to 30. So now rearrange as per the order 1, 2, 3, 5, then after 10, 15, 5, 6, 10, 15. Okay, 5, 6, 10, 15 and 30. Clear? So this way we can check the sub-Boolean algebra for the given set. And now consider it total. So for a 2 element we have the 1 set. For a 3 element we have, for a 4 element we have the 3 set. And for a 8 element we have the 1 set. Okay. So answer is equal to the total sub-Boolean algebra, that is equal to 1 plus 3 plus 1, and that is equal to the of 5. Okay. So total sub-Boolean algebra we can predict is equal to the 5. Okay. So the solution is not mentioned in this slide. Just take the screenshot of this page for your reference, how we can solve this question if it is asked in the exam. So this way you can find the answer of each question. Okay, so just take the screenshot for your reference if it is required to you, otherwise just keep it. And for any doubt you can ask me, and this stone represent here. Okay, so let us solve the next question. This we have set is equal to, let us consider as 1001. Okay, it is a Boolean algebra, and let us check how many set we can predict. S1001. PCDLCM. find total sub-Boolean algebra. Okay. So first we'll consider S1001. Formula will be same in each example. Okay. That is equal to 1 and after 7, 11, 13, 77, 91, 143 and 1001. Okay, these are the element of S1001. And now just predict the atom. So it is easy to understand. Okay, 7, 11 and 13 are the covered of zero element. Zero element is here 1. Okay, you just also write down separately here. Zero element is equal to 1 and the I element, that is equal to 1001. Okay, it is equal to 7, 11 and 30. Okay, the three value are the atom. And now let us find the sub-Boolean algebra for two element. So the formula we have in the case number 1, okay, S is equal to 0 comma I, and that is equal to 1 comma 1001. Okay, so this is sub-Boolean algebra which contain the two element of S1001. And then after in case number 2, we'll identify a sub-Boolean algebra which contain the four element. So this can be write as a S is equal to 0 and after A, n by A and the I. So 0 means 0 element, okay, not a single 0. So there are three atoms, so use it one by one. So S can be write as a 0. Let's use the A is equal to 7. So 1 comma 7, then after 1001 and it is 7 and I element is a 1001. Okay, so 7 after 1001 by 7 and I is equal to 1001. Okay, so is equal to 1 comma 7 and after divide by 7 will be 143 and then after 1001. Okay, and then after second atom you can use here 1, then after 11, 1001 by 11 and then after 1001. Okay, so it is equal to 1, 11 and divide by 11 will be 91. Okay, and that is equal to 1001. And third set you can create because there are three atoms, that is here 13, 1001 divided by 13 and 1001, and that is equal to 1, 13, here it is divide by 13, that will be 77 and 1001. Clear? So this three set you can predict which involve the four element. Okay, and these are known as the sub-Boolean algebra of the main set. Okay, and now in case number 3 you can predict a sub-Boolean algebra which contain the 8 element. So the formula we have S is equal to 0, 0, then after A, n by A, B, n by B, and then after LCM of A comma B and LCM of n upon LCM of A comma B and then after I element. Okay, so replace all the value there. You can consider any value as A and B from the atom. 7 and 11, 7, 13, 11, 13, use any one, you will get the same answer in each case. So 0 element is equal to 1 and let us use A is equal to 7 and b is equal to 11. Okay, so 7, then after 1001 divide by 7, b is 11, it is 1001 by 11. Then after LCM of 7 and 11, and n upon 1001 divided by LCM of 7 comma 11, and I element is 1001. Okay, so this is equal to 1. Then after 7, 1001 by 7, that will be 143. 11, 1001 by 11, that is equal to 91. And then after LCM will be 77. Okay, 7 into 11 will be 77, and 1001 by 77, 30, last entry is a 1000. Okay, so just rearrange 1, 7, 11, 13, then after 77, 91, 143, and 1001. Okay, so now find the total sub-Boolean algebra. So total is equal to, there is a one set which contains the 2 element. Okay, then after there is a 3 set which contain the 4 element, and the one set which contain the 8 element. So answer is equal to the part. Okay, so is it clear? Is there any doubt to anyone in this topic of stone represent theorem? Yes, remaining student, is there any doubt? So you can ask me. Okay, good. So now next topic, this unit is a Boolean expression and variable, and you can also try some remaining example which is mentioned in the assignment to find the total sub Boolean algebra. Okay, the formula will be same that. Okay, set will be different. Okay, S1001, S30, any set will be given that which is a Boolean algebra. Okay, and then after you have to identify a total sub Boolean algebra by using stone represent here. So formula will be same. There is a 3 formula we have. Okay, case 1, consider 0 and I element. So find the first entry of the set and the last entry of the set. These are known as a 0 and I element. So that is simple. In case number 2, we required the atom. Okay, so first find the atom of the given set. And this answer of case 2, it depends on the number of atom. Okay, if it is contain the 2 atom only 2 atom, then we'll get only 2 set. Okay, if it is contain the 4 atom, then we'll get a 4 different set. Okay, so formula is a 0 element A, n by A, and the I element. Okay, so use one by one each atom and predict the set. Okay, so 3 set we can predict. Why? Because we have the 3 atom in the example. And in case number 3, we can predict the answer of sub-Boolean algebra which contain the 8 atom. So how we can derive this set? So there is also one fixed formula, 0 A n by A, B n by B, then after LCM of AB, and n upon LCM of AB, comma I. So consider any two value from the atom, okay, as a and B, and you will get the same answer in each case. Okay, सभी में सेम ही आंसर मिलेगा. अगर आप 730 की पेयर बनाओ, आप 1130 की पेयर बनाओ, okay, you will get a same answer at last. So we'll get a same set, okay, which is a part of S1001. Okay, you just compare that. It is also involve the 8 element. Okay, and we'll get the same answer in the case number 3. Okay, why it is same answer? Because it is a sub Boolean algebra. It is a Boolean algebra by using a Stone theorem. okay, which contain the 2 raised to n element, okay, 2 raised to form element, okay, 2 raised to n. So therefore it is a Boolean algebra, and therefore we can predict the answer of sub Boolean algebra, okay, and this way you can check the answer. So solution is not mentioned in this slide. Just take the screenshot for your reference. It is required to you. How we can solve it if it is on the exam. Okay. So is there any doubt up to this topic to anyone? Okay. So let's start the next topic of this theory. Just give me the 1 minute. Let us change the slide. Okay. So next topic of this unit is a Boolean expression. So let us check first its definition, and then after we'll solve it some counter example. Boolean expression, how we can define it? So we have one set which include the 0 and 1, the binary value that is known as a B, and then after B raised to n, that can be defined as a n entry as x1, x2 up to xn, okay, where xi belongs to the B, and the variables x1, x2 up to xn are known as a Boolean variable, which takes the value from the set B, either it is 0 and 1, therefore it is said a Boolean variable, okay, Boolean element. And now we consider the function from f from b raised to n to b, okay, this function is known as a Boolean function of degree n, okay. We have one set b is equal to 0 and 1, and now consider b raised to n, okay, which involve the n entry as the x1, x2 up to xn, and then after where all the xi, okay, means x1, x2, xn belongs to the b, either it is 0, otherwise a 1. They are known as a Boolean variable because it takes the value from the set B. It means either it is 0, otherwise a 1. Okay, so therefore it is known as a Boolean variable. And now we consider one function f from b raised to n to b is called a Boolean function of a degree n. Okay, b raised to n means this is the input set here, x1, x2 up to xn, and we'll get it output to the b. Okay, means the output will be either 0, otherwise a 1. Okay. And now we consider the expressions form. Okay, the expressions made from the Boolean variable. Okay, we'll use this variable and we'll create one expressions form by using a binary operation star and ring sum. Okay, which is known as a Boolean expression. So the expressions made from the Boolean variable and its logical outcome, it is either 0 and 1. And there is one counter example for that. That is x1 star x2. Okay, we'll consider the input value from the b, okay, b raised to n, that is involve x1, x2 up to xn, and now use the two binary operations star and ring sum and create one expression. Okay, and when we solve it outcome, okay, we'll get either 0, otherwise a 1. Okay, so x1 star x2, okay, that is a Boolean expression. That is a complement x1 dash star x2 star x3. Okay, any form you can consider here. And then after for a ring sum x1, ring sum x2, ring sum x3, and so on. Okay, so these are the few example of Boolean expression. Okay, we'll solve it. Okay, and we'll get it output either it is 0, otherwise a 1. Okay, so this is the definitions of Boolean expression, how we can define. And are the few properties for that. 0 and I element, okay, are also the Boolean expression. So how we can define 0 element and I element? So 0 element can be considered as a x1 star x1 dash. Okay, x1 dash is a complement element of the x1. So by using star operations, you have to just combine it as a x1 star x1 dash. Okay, so that is equal to the 0 element, x1 star x1 dash. You can also consider a second element, x2 star x2 dash. Okay, that is also 0 element, x3 star x3 dash. That is also 0 element. Clear? And I can be defined as x1 ring sum x1 dash. Okay, by using ring sum, you will get I element, and by using the star, you will get a 0 element. So x1 ring sum x1 dash, that is equal to I, and x1 star x1 dash, that is equal to 0. Okay, you can also change the element there. Let us consider a y. So y ring sum y dash, okay, that is equal to I, and y star y dash, okay, that is equal to 0 element. Clear? uh, Combined by using a star with its complement, that gives the 0 element, and combine it by using a ring sum with the complement element, that will gives the I element. Okay, element may be anyone. So this formula will use to check the next theory, product of sum and sum of the product. Okay, so this both formula will used in this theory, and is also very important formula for a 1 mark short question, otherwise 1 mark MCQ. So what is the answer of x1 ring sum x1 dash? Okay, what is the answer of x1 star x1 dash? So that is equal to 0, and that is equal to I. And if we change the element, okay, if I consider z ring sum z dash, that is also the I element. Okay, if I consider x5 ring sum x5 dash, that is equal to also the I element. Clear? Then second condition that if alpha of x1 x2 up to xn and beta of x1 x2 up to xn are the Boolean expression, then alpha star beta, okay, and alpha ring sum beta are also the Boolean expression. Okay, that is one simple to data here. Alpha and beta, alpha involve the x n values, beta is also involve the n values there. And now consider its star product and the ring sum. So alpha star beta, okay, and alpha ring sum beta are also the Boolean expression. And third one, x dash is also the Boolean expressions for every Boolean expression x. Okay, if x is a Boolean expression, simple x, okay, only one element there. If x is a Boolean expression, then its complement x dash is also the Boolean expression. Okay, if y is a Boolean expression, then y dash is also the Boolean expression. Clear? So any Boolean expression you can consider which involve the single entry, then its complement means x dash is also the Boolean expression. Clear? So these three simple rules we have. The first one is very important in the next theory, how we can consider 0 element, that is x1 star x1 dash, and I can be defined as x1 ring sum x1 dash. Okay, for ring sum we'll get an I element, and for star we'll get a 0 element. And then after second one, for alpha and beta case, alpha star beta and alpha ring sum beta are also known as a Boolean expression. And third one, x dash is complement element, is also known as a Boolean expression. Okay. And then after min term and max term. Okay, so how we can derive the min term and max term for the 2 variable, for the 3 variable, 4 variable, and so on. But in our syllabus, we'll have the two types of case, 2 variable and 3 variable. So this is a procedure to check the min term and max term for the 2 variable as well as 3 variable. Okay, so what is that? In min term, okay, x dash will consider as a 0, and x will and in next term it is reverse, x dash will consider as a 1. Okay, again I repeat that min variable का मतलब क्या होगा, that is a 1, and now in next term Just 1 minute, please. Okay. So let us derive the table of minterm and maxterm for two variable. So when you consider two variable, there is four possibility. Either both are true, true, false, false, true, and false, false. Okay, means both are 0, 0, 1, 1, 0, and 1, 1. And that we consider it as definitions as true and false. Okay. So both are 0. So how we can create a minterm expressions for that? So expression we consider as a, okay, as we know that x dash consider as a 0 and x is equal to 1. Okay, means the complement element will be 0 and normal element will consider as a 1. Okay, so both are 0 that. Okay, so what does it mean? Okay, both will be the complement element. Okay, and we consider as a minterm. So for minterm we'll use the star. Okay, that is for minterm operator, and for maxterm we'll use the ring sum. Okay, we'll combine by using a star in minterm and we'll combine by using a ring sum in maxterm. So minterm expression can be defined as a both are 0 that, so it can be write as a x dash star of y dash. Okay, again I repeat that both are 0. So in minterm case x dash will consider as a 0 and x will consider as a 1. Okay, in minterm, and then after we'll consider for maxterm. Okay, so both are 0 that, so it can be defined as a x dash star of y dash. Okay, and now how we can say it is equal to small m0. Okay, so that is one procedure that let us first check this procedure. Okay, what the data we have? We have the data is x dash star of y dash. Okay, these expressions we have, and now you have to say it is a small m0. So how we can say it is a m0? Okay, that is a minterm value 0, 1, 2, 3, and so on. Okay, m0, m1, m2, m3, and so on. So how we can derive this m0? So you have to apply the 2 raised to n sequence, okay, to this expression. Means for 2 raised to 0, 2 raised to 1, 2 raised to 2, and so on. Okay, so this is your first entry. Okay, the second variable y dash, यहाँ से आपको start करना है, ठीक है. So y dash, and what is meaning of dash? That is means of 0. So 0 multiplied by 2 raised to 0. Okay, the first term of 2 raised to n, that is 2 raised to 0. Then after add a 2 raised to 1 to the first entry. So x dash, what is meaning of x dash? That is also 0. So it is 0 into 2 raised to 1. Okay, again I repeat that we have expression is x dash star y dash. Okay, और आपको ये वैल्यू डिराइव करनी है m0 की, तो कैसे आप डिराइव करोगे उसको? So apply the sequence of 2 raised to n, okay, to this each term. So first term is the y dash. So apply to the 2 raised to 0. And what is meaning of y dash? That is a complement element. So what is meaning of complement element? That is known as a 0. So consider here 0 into 2 raised to 0. Okay, then after add plus, okay. Next term is the x dash. That is also the complement element. So what is meaning of x dash? That is 0. And what is the next term after 2 raised to 0? So 2 raised to 1. Okay. So multiply by 2 raised to 1 to this term. So what is now total? 0 into 2 raised to 1, that is 0. And 0 into 2 raised to 0, that is also 0. So answer is equal to 0. Okay. So therefore I consider here small m0 for min term, and for max term we'll consider capital M0. Clear? So therefore it is M0. So let us check each one, and then after we'll consider for max term. Okay. Second possibility for 0 and 1. So for 0 and 1, how we can create expression? That will be the x dash star of y. Okay. Because second element is 1, that, and what is meaning of 1? That is a normal value. Okay. In min term. So that is a y here, and x dash, that is a 0 here. Therefore I consider x dash complement. Okay. So x dash star y, and y it is m1. Okay. Y it is m1. Let us check. So first term, that is a y, and what is meaning of y? That is normal value, so it is a 1. So that can be write as a 1 into 2 raised to 0. Okay. Plus, what is meaning of x dash? That is 0 into 2 raised to 1. Okay. So what is the total? 0 into 2 raised to 0, that is 0, plus 1 into 2 raised to 0. So 1 into 2 raised to 0 का मतलब क्या हुआ? That is a 1. Okay. So answer is equal to the 1. Clear? So therefore it is a m1, x dash star y, that is equal to m1. Clear? Now third one is there 1 comma 0. So what is the Boolean expressions for 1 comma 0? That will be the x star y dash. Okay. X is the normal value because it is a 1 here. X की value 1 है, or y it is a 0, that therefore it is a complement. Okay. So x star y dash. So y it is a m2. So apply the sequence of 2 raised to n form. So first is a y dash. So y dash means a 0. Okay. So 0 into 2 raised to 0 plus x means a normal value. It is a 1 here. So 1 means 2 raised to 1. Okay. 1 into 2 raised to 1. So what is the total? 1 into 2 raised to 1, that is a 2. And plus 0 into 2 raised to 0, that is a 0. Okay. So therefore is equal to the 2. Okay. So therefore answer is equal to the m2, small m2. Okay. For min term. And now last case 1 comma 1. Okay. Both are normal value. Okay. So x star y, that is a Boolean expression. So what is the answer of min term? That is m3. Why it is m3? Because value of both normal variable, that is a 1, that. So 1 comma 2 raised to 1 plus 1 comma 2 raised to 0. So what is the answer of that one? So that is a 2 raised to 1 into 1. It is a 2 plus 1 into 2 raised to 0. That is a 1. Okay, 2 raised to 0 is 1, that. So 1 into 1 is also 1. So answer is a 2 plus 1, that is equal to 3. Okay, so therefore it is known as a M3. Is it clear to all? Is there any doubt in this evaluation of min term? Then after we'll discuss the max term case. Okay, so is there any doubt to anyone? Okay, good. सिर्फ आपको एक सिंपल प्रोसेस अप्लाई करनी है to derive the M0, M1, M2, M3 and so on. Okay, it depends on the expression, which expression is given there. Okay, and the rule is already mentioned in this slide के dash का मतलब means complement का मतलब 0 है, और normal variable का मतलब है 1. Okay, in min term, और max term में इससे उल्टा करना. So is there any doubt to anyone? Is it cleared? In the evaluations process of min term. Yes, Jeet, Jai, Manan, Tejas, Yatin, Vivek. Is it cleared? Is there any doubt? Okay, good. Okay, okay. So let's check for answer of max term. That is also simple, that, and answer also same. Okay, the answer of min term is same as answer of max term, but just symbol is changed. Okay, here it is small m0 in the answer of min term, and here we will use the capital M0. Okay, answer also will be same. That why it is the same, let us check. So expression of max term, okay, for a 0 comma 0. So in the max term normal value, okay, consider as a 0, and the complement value consider as a 1. Okay, x dash is 1 and x is a 0. Clear? So expression will become x ring sum y. Okay, for a max term we'll use the ring sum, okay, and for min term we'll use the star. So x ring sum y, and y it is a capital M0. So let us apply the procedure to check the answer of capital M0. Okay, suffix value हमें predict करना है just. So x ring sum y means that is 0 into 2 raised to 1 plus 0 into 2 raised to 0. Okay, that is a form x ring sum y. It is given. So first variable is a y, and what is meaning of normal value? That is a 0. So 0 into 2 raised to 0, and second value is also normal variable here. So 0 into 2 raised to 1. So what is the total? That is a 0. So it is right capital M0. Okay, and after second is a 0 comma 1. Okay, so 0 means x and 1 means y dash. Okay, so x ring sum y dash, and what is the answer of x ring sum y dash? That is equal to 0 comma 2 raised to 1 and plus 1 comma 2 raised to 0. Okay, because y dash is a complement value and y dash means 1 and normal variable means a 0. So what is the total? It is a first term is a 0 and second term will give a 1. So it is known as a capital M1. Okay, and then after third is a 1 comma 0. So expression will become x dash ring sum y. Okay, x dash ring sum y. Okay, so what is the answer of that one? A dash means 1. So that will be right as a 1 comma 2 raised to 1 and plus 0 comma 2 raised to 0. Okay, because second variable is a y, then it is gives a 0. So 1 comma 2 raised to 1. What is answer? It is equal to 2. Okay, so answer is equal to capital M2. And then after third one, fourth one, 1 comma 1. So what is the answer of 1 comma 1? That will become x dash ring sum y dash. Okay, x dash ring sum y dash, and that will give the M3. Why it is M3? Because that can be write as a 1 comma 2 raised to 1 and plus 1 comma 2 raised to 0. So total will be 3. Okay, so that is known as a capital M3. Clear? So this way you can predict answer of min term and max term. Okay, it is simple, nothing but difficult procedure. That it is simple one. Just you have to predict the answer of m suffix value that you have to predict. Okay, M0, M1, M2, M3 and so on, and that depends on the expression, which expression is given that. Okay, and that is for max term. For max term we'll use the capital M0. जो आंसर मिन टर्म का है वही आंसर मैक्स टर्म का बनेगा. ठीक है, बट symbol is changed. In small m0 it is answer of min term, capital M0 is answer of max term. Okay, so जिस आपको एक ही वैल्यू प्रिडिक्ट करनी है, एक ही बार ये 2n वाली प्रोसेसर अप्लाई होगी. ठीक है, नेक्स्ट टर्म का आंसर तो डायरेक्टली आपको मिल जाएगा. ठीक है, जो वैल्यू यहाँ पे है, ठीक है, यहाँ पे आपको 1 मिला है, तो यहाँ पे भी क्या होगा? कैपिटल M1 ही होगा. ठीक है, इफ इट इज M2 देन आंसर ऑफ नेक्स्ट टर्म इज ऑल्सो कैपिटल M. क्लियर? ये इंपॉर्टेंट है. ठीक है, ये जो डेटा हमने लिखा है यहाँ पे कि एक्स डैश कब 0 लेना है, कब 1 लेना है. ठीक है, व्हेन कंसिडर x इज 1, x इज 0. सो मिन टर्म में कॉम्प्लीमेंट 0 होगा. ठीक है, नेक्स्ट टर्म में कॉम्प्लीमेंट 1 होगा. ठीक है, मिन टर्म में नॉर्मल वेरिएबल 1 होगा, नेक्स्ट टर्म में नॉर्मल वेरिएबल 0 होगा. एक्स डैश इज 0, x इज 1, x डैश इज 1, x इज 0. ओके, और ये जो यहाँ पे है दिस एक्स्ट्रा पार्ट हियर, हाउ वी कैन डिराइव दिस सफिक्स वैल्यू. This is a sequence to apply that of 2 raised to n form, 2 raised to 0, 2 raised to 1, 2 raised to 2 and so on. So let us check in this for 3 variable case. X, Y, Z are 3 variable, and when we consider 3 variable we have the 8 various type of possibility. Okay, both all are 0. So which expressions you can consider in min term? We'll get here in min term. Okay, यहाँ पे मैं लिख देता हूँ for min term x dash means 0. Okay, x means 1. Clear? This is given. So तीनों 0 है, means you can create expression as a x dash star y dash star z dash. Okay, And now to evaluate the answer of small m0, okay, means why it is 0 here. So let us check it. So just apply the sequence of 2 raised to n. तो तीनों वैल्यू डैश है, ठीक है, कॉम्प्लीमेंट वैल्यू है. सो ऑल आर प्रिडिक्ट द 0. ओके, सो दैट कैन बी राइट 0 into 2 raised to 2 plus 0 into 2 raised to 1 और प्लस 0 into 2 raised to 0. यहाँ पे मैं लिखता हूँ x dash star y dash star z dash. ओके, so for z dash it can be right 0 into 2 raised to 0 plus y dash will be 0 into 2 raised to 1 and plus x dash will be 0 into 2 raised to 2. Okay, the sequence. If it is involved the 4 variable, then you can write here 2 raised to cube term. Okay, if it is involved the 5 term, then you would write 2 raised to 4 term and so on. So this is the answer of min term. What is the answer? That is equal to 0. Okay, total will be 0. So that is right, m0. Clear? And same for max term. In max term, we consider normal variable will consider as a 0 and dash will consider as a 1. Okay, so all are 0 there. So it can be write as a x ring some y ring some z. Okay, and what is the answer of this one? That is a capital M0. Clear? And then after second one, 0, 0, 1. So what is the Boolean expression that we have? That is, what is the expression of min term? X dash star y dash star z. Okay, because third term is a 1 that, so its answer will be x dash star y dash star z. Okay, and let us check the min term value. So that can be write as a 0 into 2 raised to square. Okay, then after 0 into 2 raised to 1. Okay, plus 1 into 2 raised to 0. So what is the answer of this one? Okay, total will be 1. So therefore is equal to small m1. Okay, and similarly for a max term that will consider as a x ring some y ring some z dash. Okay, इससे यहाँ पे उल्टा होगा, यहाँ पे x dash y dash है for a 0, यहाँ पे x y है for a 0. Okay, and यहाँ पे z normal value है for a 1 and here it is a z dash for a 1. So x ring some y ring some z dash, and when we find out the sequence, the answer will be 1 z. So it is capital M. Then after third one, 0, 1, 0. So it can be write as x dash star y dash star z dash. Okay, and what is the answer? Why it is m2? Let us check. So it is 0, 2 raised to 2 plus a y, that is 1 into 2 raised to 1 and plus 0 into 2 raised to 0. तो ये 0 है, ठीक है. 1 into 2 raised to 1, that is 2 and 2 into 2 raised to 2, that is 0. So answer will be 2. So therefore it is a m2. And what is the formation of this one? So that will be x ring sum y dash ring sum z. Okay, and that will be m2. Okay, you can just verify it. It is also same. Then after 0, 1, 1. Okay, so formation will become x dash star y star z, and y is m3. Let us check. Dash means 0, so 0 into 2 raised to 2 plus 1 into 2 raised to 1 and plus 0 into 2 raised to 1 into 2 raised to 0. So what is the total? First term is 0, second term will give a 2 and third term will give a 1. So 2 plus 1, that is equal to 3. So therefore it is a m3. Okay, and here the formations for max term will become x ring some y dash ring some z dash, and when we find the answer of capital M, will also give a 3. Okay, and then after fourth term, fifth term 1, 0, 0. So that will write as a x star y dash star z dash. Okay, and that is m4. Why it is m4? Let us check. The first term is a x, so it is 1 into 2 raised to 2 plus 0 into 2 raised to 1 and plus 0 into 2 raised to 0. So what is the total? It is a 4. So therefore it is m4. Okay, and here will become x dash ring sum y, ring sum z, that is M4 also. Okay. And then after a 101 case, so it will become x star y dash star z dash, and y is M5. Let us check. 1 into 2 raised to 2 plus 0 into 2 raised to 1 and plus 1 into 2 raised to 0. So what is the total of this one? That is a 4 plus 0 plus 1 is equal to 5. So answer is equal to M5. And here the next term will become that is a x dash ring sum y and ring sum z dash, that is equal to capital M5. Okay. And then after for 110 case, the expression will become x star y star z dash, that is the M6. Why it is M6? Let us check. The first term is x, so it is 1 into 2 raised to 2 plus 1 into 2 raised to 1 and plus 0 into 2 raised to 0. So what is the total? It is a 4 plus 2. Okay. First term will give a 4, second term is a 2 and third term is a 0. So answer is M6, and here this formation will become x dash ring sum y dash ring sum z, and that will also give M6. Clear? And last case 111, so expression will become x star y star z, and here y is M7. So because it is 1 into 2 raised to 2 plus 1 into 2 raised to 1 and plus 1 into 2 raised to 0. So total will be 4 plus 2 plus 1, that is a 7, and therefore it is M7, and here will give x dash ring sum y dash ring sum z dash, that is equal to capital M7. Okay, so this way we can predict the answer of max term and min term for a 3 variable case. Okay, so is there any doubt in this both table? Is it clear? Is there any question, any query? Okay, good. Okay, so let us implement this concept to the various example. In this we'll find the min term and max term for the following data. Okay, we have one different type of set that binary value is there. Okay, 1011, then after second is 101, and similarly for third one. Okay, so find out in min term and max term. Clear? So first is a 4 variable set there. Okay, because there are 4 output 1 0 1 and 1. Okay, so it involves the 4 variable set. In this both table, okay, we consider the 2 variable and 3 variable, and it's all possible outcome. And now in this data we have the 4 variable set. The procedure is the same, that there is no any change there. Just follow the sequence of 2 raised to n, okay, properly, then you will get a right answer at last. So first create expressions for min term. Data is 1 0 1 and 1. Okay, so what is the meaning of 1 in max term, min term, and what is meaning of 0 in min term? So 1 means a normal value and 0 means a complement value. So use the proper sequence. First value consider as x1. Okay, 1 0 1 1 है, ठीक है. So 1 consider as x1, 0 is x2 dash, x3 and x4. Okay, so x1 star x1 dash star x3 and star x4, and use it for a ring sum also. So it's the part of max term. Okay, x1 डैश रिंग सम x2 रिंग सम x3 डैश एंड रिंग सम x4 डैश. ठीक है, यहाँ से जो डिफाइन किया इससे यहाँ पे रिवर्स लेना है. ठीक है, यहाँ पे डैश में x2 है, x2 डैश दैट, here you have to consider x2 only. Clear? And remaining consider a complement. Let us derive the answer. Okay, so now find the part of 2 raised to n. So that can be write as a normal value means 1 and complement means 0. So x4 will consider as a 1 into 2 raised to 0. x3 will consider as a 1 into 2 raised to 1. Okay, then after x2 dash will consider as a 0 into 2 raised to 2. Okay, and then after x1 will consider as a 1 into 2 raised to 3. Clear? 2 raised to 0, 2 raised to 1, 2 raised to 2 and 2 raised to 3. Clear? And use the data 1 0 1 1. Clear? and then find the answer. So total will be 2 raised to cube, that is 8, plus 0 into 2 raised to 2, that is a 0, and plus 1 into 2 raised to 1, that is a 2, and 1 into 2 raised to 0. So 2 raised to 0 is also 1, multiply by 1, so answer will 1. So total will be 8 plus 2 10 plus 1, that is 11. So answer of min term, that is a M11, okay, small m 11. And similarly you can predict the answer of max term, that also will be same, that you just write the procedure properly and then after write directly the value capital M11, okay. First write the expression, okay, that is expressions here, and if it is required to check it is 11 or not, so just mention the procedure here to why it is 11, okay, and then after write directly M11, okay. But it will be always same, that answer of the suffix value, okay, in the min term and the max term, that will be same. Clear? Here it is a small M11 and here it is a capital M11, that is the difference. Clear? There is no any change. Clear? If it is involved the 5 entry, let us take 10111, okay. So that will be mapped to the 2 raised to 4, okay. 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4 and so. 0 से आपको start करना है, ठीक है. 2 raised to 0, this is your first term. Then after 2 raised to 1, 2 raised to 3, 2 raised to 2. Example, okay, and that is it, solution. Clear? Let us consider second one, that is a 101. So expressions for 101, okay, part of min term, that is the min term here, and that is for max term. So 101, so expression will become, normal value will consider as a 1 and 0 for complement. So x star y dash star z, you can also consider a different type of means arbitrary any element, that, okay. You can use x1 x2 x3 sequence, otherwise you can use x y z and so on, okay. It depends, but procedure will be same, okay. If you use here x1 star x2 dash star x3, you will also get the same answer. In place of that, you use the xyz notation, that is also the true. So x star y dash star z, so y is m5, let us check. So 1 into 2 raised to 2, okay, 0 से start करना है, 3 term only, so it will map up to the 2 raised to 2. So 1 into 2 raised to 0, y dash, therefore it is 0 into 2 raised to 1, and it is x only, so therefore it is 1 into 2 raised to 2, okay. So total will be 4 plus 0 plus 1, so is equal to the 5, okay. So therefore answer is equal to the m5, okay, small m5, that is answer of a min term. And now let us check for max term. So the expression will become x dash ring sum y, okay, ring sum z dash, okay, that is a form of max term. X dash ring sum y ring sum z dash, and you can also check it is a 5 here, and why it is m5, you can verify it by using the procedure. So dash means 1 in the max term, so it is a 2 raised to 2 plus 0 into 2 raised to 1 and plus 1 into 2 raised to 0. So total will gives the 5 again, therefore it is a m5. Clear? And then after third one, all are 1, okay. So let us check it. Answer of min term and max term. So first let us create the expressions. Will gives here x star y star z, otherwise x1 x2 x3, of course you can also use that. W. Okay. For a max term, all are 1, therefore there is no any complement entry. We'll consider that, because next term 0 that and min term is 0 that, then we'll consider a y dash. Okay, so there is no any 0 there, so all will be the normal value and we'll consider as a 1. So answer will be 1 into 2 raised to 3 plus 1 into 2 raised to 2 plus 1 into 2 raised to 1 and plus 1 into 2 raised to 0. Okay, we'll start with the 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, and so on. So now find the total. So that is a 8, and after 4 plus 2 and plus 1. Okay, so that will be 14 plus 1, that is equal to 15. Okay, so what is answer of min term? That is equal to m50. Clear? Answer of min term, that is equal to m50. And now similarly for min term, just expression will be modified here. Here will become x dash ring sum y dash ring sum z dash ring sum w dash. Okay, this is answer of max term. And here we'll get the same value, 1 into 2 raised to 3 plus 1 into 2 raised to 2 plus 1 into 2 raised to 1 and plus 1 into 2 raised to 0. Okay, that is also give the 15 there, and therefore answer of max term, that is equal to capital M15. Clear? So now, any doubt to anyone in this type of questions? Okay, so try to the fourth one. Okay, a fourth example try karo, and what is answer of min term and max term? 1011. Okay, there is a 4 term is given there, so just check it and reply your answer in the comment. Yes, it is a M11. Let us check why it is a M11. Okay, so important in this type of question. Okay, if it is asked for 2 mark, okay, 2 to 4 mark, then first this expression is important. Okay, that should be the true, and then after this evaluation. Okay, and based on these evaluations we can predict the right answer. Okay, if any data is incorrect in this pair, then you will get a wrong value at last. Okay, so first take it and remember the रिजल्ट वन. सो जो नोट है हमारा वो आप याद रखना कि एक्स डैश कब 0 लेना है, कब 1 लेना है. ठीक है, एंड बेस्ड ऑन दैट वी कैन check it. So 1011. Clear? So first expression of min term, that is x star y dash star z star w. Okay, otherwise x1 x2 x3 x4. And then after check the suffix value, and that will be 1 into 2 raised to 3. Okay, plus 0 into 2 raised to 2 plus 1 into 2 raised to 1 and plus 1 into 2 raised to 0. Okay, so this 2 raised to 4 term will become 0 there, and remaining all value we can easily derive 8 plus 0 plus 2 plus 1. Okay, so this equal to 11. Therefore the answer of min term, that is equal to M11. Okay, and similarly the max term formations will become x dash ring sum y ring sum z dash ring sum w. Okay, w dash. Clear? And similarly you will get same answer here. Okay, but the notations will be different. That is equal to capital M 50. Okay, this is for max term and this is for a min term. Clear? And next I have to try that example number 6. Insert data 110, 1 and after 1 1 0 1 1 1. Okay, so try it. First try the sixth one and then after try the seventh one.